This is the third and last pre-recorded lecture from Chapter 11, and this lecture briefly goes over how to interpret phase diagrams. So a phase diagram looks generically like I have shown down here, and I've always kind of thought it as looks like a crooked Y. But the most important thing to understand from a phase diagram is that it shows us how the phase of a substance depends not only on temperatures we're familiar with, but also on pressure. So while we talk about a boiling point or a melting point for a substance, that's really only at one particular pressure. And we can change boiling and melting point if we change the pressure. Each of the regions or sections in a phase diagram represent a single phase. So to the far left represents the solid phase, which makes sense because what are the conditions at the far left? You have low temperature, and you would expect that to be a solid. The middle is a liquid, and the far right is a gas. And I've always remembered that by saying this is the slug diagram, solid, liquid, gas. The lines represent phase changes. So this particular line separates the solid from a gas. And so going directly from a solid to gas is called sublimation. Make sure you know all these names. If you were to go the other direction, a gas back to a solid, you may not know this phrase. That's called deposition. And let's see, this line separates solid and liquid. And so going from solid to liquid, of course, is melting. And going the other way is freezing. Okay, and then finally, this is the boiling point line or vaporization curve that separates liquid and gas. So I want you to understand that these lines actually represent the conditions under which that substance changes phases. And if you're exactly on that line, for example, let's imagine we're right there, then if I were to ask you what phase or phases are present here, since it's right on the line, you would say, okay, there's an equilibrium between liquid and gas at this point. There are a couple of specific areas on a phase diagram that you need to be familiar with. One is right kind of at the apex or the junction of the Y, and that is called the triple point. That is the pressure and temperature at which a substance, all three phases are present in equilibrium. So they're solid, liquid, and gas, all in equilibrium with one another. That's pretty cool to see. I used to do an experiment that allowed you to see the triple point of carbon dioxide. One thing I left out of the slide, but that I want you to know, is at the very tip of the vaporization line is called the critical point. And the critical point is the temperature and pressure at which a gas can no longer condense. My dog is drinking in the background. One of my dogs is. Okay, so if you reach the critical point, so let's just say you're at some critical temperature. So we'll call that critical temperature X. At that temperature and above, regardless of what you do to the pressure, so usually if you have a gas and you increase pressure, usually you can cause the gas to condense to a liquid. But if you're beyond the critical point, no matter how much you increase pressure, you will not be able to turn it back into the liquid. So regardless of what you do to it beyond the critical point, it's going to stay in the gas phase. As I said in the beginning of this PowerPoint, the phase that a particular substance is depends on both pressure and temperature. And so you will alter both melting point and boiling point of a substance by adjusting the pressure. Just kind of an interesting little piece of information, and it kind of makes sense, right? Most substances will expand just a little bit as they go from the solid to the liquid. Water is an anomaly. Water actually shrinks, which is why ice cubes melt, but other than water, the vast majority of substances expand when they melt. And so if you increase the pressure, you inhibit that expansion. You kind of like say, no, you cannot spread out. So if you increase the pressure, it inhibits the melting. So the bottom line is at higher pressures, melting point and boiling point increase. Okay, so there's kind of a direct relationship there. Here are some sample questions, the type of question you might see on a quiz or an exam. And take a stab. I recommend that you turn off the video for just a moment and see if you can answer these 3 questions on your own. And then I will discuss the answers. Alrighty. Question number 1. At 30 atmospheres of pressure, so I would go ahead and make a little tick mark there, the melting point of this substance is what? The first thing I would do is probably label the curve so I don't make a silly mistake. Slug, solid, liquid, gas. And I would probably also label the phase changes. So solid to gas, that is sublimation. Solid to liquid is melting. And liquid to gas is vaporization. Okay, just so I don't make a silly mistake. So if I'm at 30 atmosphere, that's very high pressure. Remember, normal atmospheric pressure is 1. The melting point of the substance, so I want to go to the melting curve. Make sure you go to the right line. And then I want to drop down and see what the temperature is. So it's around 0 degrees Celsius. Let's see, at STP, the substance exists as now you have to think back to 1211, that's standard temperature and pressure. So standard pressure is 1 atmosphere. Standard temperature is 0 degrees. And so let's look at this for a minute. Let me get rid of all the marks. Alrighty, so let's see, STP. So we want 0 degrees Celsius and 1 atmosphere. Okay, so under those conditions, the material is a gas. All right, and finally, if the temperature is held constant at negative 25 degrees, what phase change occurs as pressure increases? So negative 25 degrees is around there, and it's saying that we're going to start at pressure of 1 atmosphere, and that we are going to, let me get rid of this black line here. There we go. So we're going to start at 1 atmosphere, and we're going to hold it at negative 25 degrees, and we're going to take it all the way up to 30 atmospheres. What phase change did we undergo? Well, we went from a gas to a solid. Okay, remember this section is gas, this is solid. So what is that called? What phase change is that called? A gas to a solid is called deposition. Okay. So those are typical questions you might be asked about a phase diagram. And that is it for this PowerPoint.